Now, another thing that you can do with your big F of x or your cumulative distribution function is you can use it to find quartiles, and that includes the median. The thing that you've got to be really careful of is to remember what you're finding the quartiles of. You are not looking for quartiles of the possible values. You're looking for quartiles of the probabilities. Now, when you graph big F of x, which I'm going to keep saying big F of x so you don't get mixed up, this is looking at the cumulative probability distribution polygon. And it has so many infinite little dots that it's actually joined up to form a function. And in the example we just looked at with the chook, we saw that it had an equation which we understood. It had x squared on 36. And so we knew that it was basically a parabola. Now, we know that if you're at the top end of the range of values that x could possibly take, which in that case was 6, you're going to be at a certainty, and that's because big F of x is the probability that your outcome is less than or equal to a certain thing, and you're certain it's going to be less than or equal to the maximum thing that it could possibly be. And so if you're looking for the median of the probability distribution, you don't want, and you had 0 meters to 6 meters here with the example with the chook, you don't want 3 meters as the median thinking that it's halfway. No, what you want is the halfway point in your probabilities. And that could equate to a point that's nowhere near halfway along the x values. So it makes sense that if you're finding the median, you're going to look for the Q2, you're going to let big F of x equal a half. So for our example with the chook, we knew that big F of x was x squared on 36. So if we let that equal a half, then we're basically solving 2x squared is equal to 36, so x squared is equal to 18. So then you would say that x is equal to the square root of 18. Now, I'm not going to say plus or minus square root of 18 because in this scenario, x had to be between 0 and 6, didn't it? So I only really want the positive answer. And instead of writing square root of 18, it would be nicer to say 3 root 2. Now, what that means is that for our chook that was wandering around its enclosure that had a 6 meter radius, what we found then is that you can define an area by finding an area of 3 root 2, however far out that is, and say the chook is in that space roughly half the time. Now, can you define a space that the chook is in a quarter of the time? Well, easy. You could actually just divide it up into quarters like that and say it's in this quarter a quarter of the time. But the context was we're looking at distance from the radius, distance from the centre. So if you wanted to find an area out from the centre, a particular radius, wherein the chook was a quarter of the time, you'd have to let x squared on 36 equal a quarter. So now you'd be saying that x squared must equal 9. So x would have to equal not plus or minus 3, we only want 3. So in other words, if you go halfway along the x values in this example, what you actually get was only a quarter of the probability. And you'd have an error in here where the radius is 3, and you could expect that the chook would be in there a quarter of the time. Similarly, you could find the Q3 by letting x squared over 36 equal 3 quarters. So then x squared would have to be 27, and x would be not plus or minus, just plus square root of 27, which I'm going to write down as, what's that, 3 root 3. So in other words, if you made a radius of 3 root 3, drew the circle, then you'd be able to say that the chook was in that area inside that roughly 3/4 of the time, and that would equate to something that's out here. And you can see that in this example, even though I've just done a rough sketch and it's not perfect, it's much more than 3/4 of 6 to find that area that contains 3/4 of the results. So down in this big box here, I think we should write this down and put a box around it as important stuff. What I've done here is I've changed our definition slightly. Why have I done it? Well, it's easy to start with this one and say, let's call big F of x the probability that our outcome is less than or equal to something. That made a lot of sense to begin with, conceptually. But let's just expand our understanding a little bit by saying, let's now redefine it as the chance that our outcome is less than or equal to something, but also greater than or equal to something. Now, in this example here, we saw that the logical lower limit for our radius was 0, because we were wondering how far this chook was from the centre. But there's going to be other examples that are a little bit different, where we might not have our CDF actually going through the origin. So we need to be able to deal with those, and that's why I've come up with a more general rule here. So here I've drawn another version of a cumulative distribution function, and again it has probabilities that range from 0, or an impossibility, through to 1, which is a certainty. But the difference is that this one doesn't actually go through the origin. Instead, it looks at various values of x that could range from a lower limit of a up to a higher limit of b. And so that's what we've got here. The interval is from a to b. And when we find these probabilities, we're basically saying, let's call x anything we like. Let's grab another pen. And so what if x was, say, here? Then if we found the probability, or in other words, the cumulative probability of x, then we'd basically be looking at what's the probability that our outcome is this or less? What about if it's this or less? What about if it's that or less? And when choosing where x can be and saying what's the probability that it's there or less. But we're keeping in mind that it's always got to be bigger than a, because we've said that a is the lowest level that it could possibly be. Now this broader definition just allows us to have more types of curves that will fit our understanding. And it makes sense then that if you sub in a, you're finding the probability that your outcome is less than a, well that's going to be impossible because it's already defined as the lower limit. So that'll be 0. It's the probability that's less than a. And if you say what's the probability that our outcome is equal to or less than b, well that would be 1 because it's a certainty, and that's because b is defined as your upper limit. Now I've put dotted lines on the end of this function here to acknowledge that sometimes we have an equation for this curve, even though there's only certain parts of the curve that fit our question. So in our example with the chook, we knew that we had a parabola. We also knew that we didn't need the other side of the parabola. So I've put dotted lines in there because this line here shows my understanding of what that graph looks like, and yet I know that that part isn't going to be relevant to my question. And that's another reminder that when you do questions with these CDFs, you need to start by defining your domain and thinking about where your graph makes sense.